Hello everyone, welcome back to this video series where we're looking at the November 2018 paper for grade 12 mathematics paper 1. So this is question 2 as we can see here. Question 1 has been done in a previous video, and in that video I go on about how we want to budget roughly 1 mark 1 minute per 1 mark, yeah, something like this. So on a 16 mark question you want to spend maximum maybe 20 minutes. Okay, always good to have that in mind when you're actually taking the exam. Of course, for this video we'll spend as much time as required to understand each question. So starting off with question 2.1, they give us a quadratic sequence. Now, this is a bit of a tricky question because in our formula sheet, we're not given the form of the equation that represents a quadratic sequence. Yeah, it's not given to us. So you gotta know it. It's not given in the formula sheet. So bit of a tricky one, but I'm sure if you've done sequences, you should know this formula, right? So the nth term is given by this form. Okay, and interestingly, you actually just get a mark for writing this formula down. So it's a good thing that once you see quadratic sequence, just write this formula down. You should know it by head, and you get a mark for that already, especially when it comes to question 2.1.2. One of these 4 marks is just for writing down the sequence, the form of the equation that represents the sequence. Anyways, so let's do some analysis on this sequence they've given us. So there's a whole bunch of different ways that one can do this, all sorts of different tricks and methods, but the way I like to do it is just find the difference between all the terms. So between 2 and 3 the difference is +1, between 3 and 7 the difference is +7, between 10 and 23 the difference is +13. And because it's quadratic, we can see that we don't exactly have a pattern yet. So let's repeat that process and find the difference between the numbers again. So the difference between 1 and 7 is +6, and between 7 and 13 again is +6. Okay, now we have enough to get a pattern. Yeah, so the difference between each number is changing by 6 each time. Okay, I hope you can see that. So that means for the next number, the difference will be 6 again. 13 plus 6 is 19. 23 plus 19 is 42. Okay, so the next term in the sequence is simply 42. Yeah, so that's, I hope you can see that. It's finding the difference between all the terms is really easy. It works as long as the sequence is not too complicated, but I think this is as complicated a sequence we can get. Yeah, so that's good for 1 mark. Now, determining the nth term of the sequence, yeah, this gets a little bit tricky, especially if you're unfamiliar with quadratic sequences, because like what we're given in our answer in our formula sheet is we're given this and we're given this, and both of them don't really work in this case. Yeah, they don't, but okay. So the difference of the difference is 6. So we need to figure out what each term A, B, and C are. That's what we need to do. So we know that A is always our difference. Yeah, it's the difference of the difference. So we're gonna write down an equation that looks like this: 2A equals 6. Okay, and is from this, it's very, I guess knowing that this is what you have to do is the hard part, but once you have this, it's very easy to see that A just equals 3. Okay, yeah, so where does that leave us? That leaves us with something like Tn equals 3n squared plus Bn plus C. Okay, now there's a couple of different ways you can try to figure out B and C from here. You can, for example, I guess substitute in some values. So this is a bit of a longer way, but it is maybe easier to see. So you can just substitute in the first term. Yeah, so we know the first term equals 2. So T1 would look something like, substitute n for 2. So 2 squared is 4. 4 times 3 is 12. Plus I haven't done this correctly, sorry. N equals 1, so this just stays 3, plus B plus C equals 2. And then we can set up a second one for T2. So now N equals 2, yeah, so this is 12 plus 2B plus C equals 3. Okay, now we have two equations. We can actually do some work on these equations, yeah. So we can say something like, from here B plus C just equals -1, and from here we can say 2B plus C equals -9, and we have these two equations. Now we just subtract them, yeah. So 2 minus 1. So if we subtract these equations, we can see that we're going to end up with the C's canceling. Yeah, C cancels. 2B minus B is just B, and then -9 minus 1 is just -8. Yeah. Okay, so we figured out A, we figured out B, so we just need to figure out C. So we can really just like substitute the value for B into 1. So B into 1, and we get something like -8 plus C equals -1. So C just equals 7, I believe. Okay, now we rewrite the whole thing, right? So Tn equals, we said our A is 3, so 3n squared, plus our B, -8b plus 7. So you could just rewrite, just rewrite this as a negative. And yeah, that's it. So I guess, yeah, you just need to know this equation. That's the hard part. So you get a mark for figuring out A, B, and C, and a mark for writing down this equation, and of course getting the final answer. Yeah. So you just need to know, you need to know that. Okay, calculate the 20th term of the sequence. So that's very easy. Now that we have the equation, they want us to calculate T20. So 320 squared minus 8. Why did I say B here? apologies, this should be n. Honestly, you can just plug this into your calculator and you should get 1047. Okay, good. That's 2 marks. Okay, now given the arithmetic sequence, okay, so now the formulas they've given us at the end of our question paper are actually applicable, yeah? So let's find the difference. So the difference between 28 and 35 is -7, 28 and 21 is -7 as well. So the sequence is decreasing by 7 with each step, okay? Calculate which term in the sequence will have the value of -40. Okay. So at this point, I'd suggest just look up the formula if you don't know it. This is the formula we're going to use. Tn a plus n minus 1 d. Okay. So Tn a plus n minus 1 d, yeah? Okay. So we want to know which term, so which term equals -140. Okay. And we can see it'll be quite a high term, honestly. So first, okay. So our first term in the sequence, you can do this a couple of different ways, actually. You can decide what the first term is. For this one, let's just imagine there was another term here. Yeah, 42. It makes it a bit easier, I think. But you don't have to do this. So you can say our first term is 42. And then the difference is -7. No. No, you don't have to do that. Why am I complicating it? Yeah, so the first term is just 35 plus, yeah, n minus 1, and the difference is -7. And then we can expand the bracket, so we'll get -7 plus 8 plus 35. And when you rewrite this, you will get something like Tn. There's an n here. Yeah. 8 plus 35 is 40. Oh, why did I say 8? This should be 7. -7 times -1 just gives 7, yeah? So 7 plus 35 gives 42 minus 7n. Okay? Or you can rewrite it whichever way makes sense, same difference. Okay, so now we have the equation of the sequence, yeah? We just want to figure out which term equals -140. So we just make Tn equal -140, and then we have -7n plus 42. And then we need to solve for n. That's all we have to do. So take 42 the other side, so we'll get -182 equals -7n. Divide both sides by -7, and we get n equals 26. And that's our answer. Okay. Good. The last question, question 2.3. For which value of n will the sum of the first n terms of the arithmetic sequence in question 2.2 be equal to the nth term of the quadratic sequence in question 2.1. Ah, this is really a really tricky question. So here, let me just make some space here. Here we're going to use our sum equations. Yeah, we're going to find the sum of the sequence. Once I'm just done making space. Okay. Let me actually just get rid of all of that. Okay, good. So here, if we go to our formulas, we're going to make use of this formula right here. Yeah. This is the formula that we're going to make use of. Okay. So the first thing to do, well, it's not exactly that formula, but close enough. What you need to see, well, what you need to know is that there's this formula. Yeah. And then I guess we should just write down, yeah, let's subs in our numbers. So yeah, we don't know what n is, right? We're trying to figure out n. And then of course, we'll just put in our equation that we just figured for the arithmetic series. Plug in the numbers. Yeah. Yeah. Okay. Okay, so I hope you can see that. Just simple subs in. Yeah, maybe we can simplify this some more. Yeah, we can like add 35 and 42. And we get 77. Okay. I guess we can get rid of the brackets as well. Might as well just do this work now. So n over 2 times negative 7. So we'd have negative 7n squared over 2 plus 77n over 2, yeah? And now the trick is to just, so we have the sum of our arithmetic series and we want to know at what term n does this sum equal the same value in the quadratic series. So we just need to equate the two. Yeah, so that's the trick to the question. So the trick to the question is to see that after simplifying our sum, we then equate this to the equation for the quadratic series that we figured out earlier. Yeah. Okay, and now we basically just need to solve this for n. Yeah. Oh yeah, let me also point out that, okay, this formula that I used here actually wasn't in the formula sheet. The one in the formula sheet was more like this. This might be easier to use, but I will say you'll arrive at this expression either formula, whichever way you decide. Yeah, and then you subs in your numbers. I mean, you'll have 2 times 35, which is 70, plus n minus 1 times our difference of negative 7. So we'd have negative 7n plus 7. And you can see that this becomes 77 minus 7n, yeah, which is exactly what we have here. So whether you actually use this equation or this equation, I find this one easier, but both will get us to the same place. Okay. Sorry if that was unclear. I just realized I just naturally used a different equation. But this is the one that's in the formula sheet, and you'll get the same answer. Okay, so what can we do to solve here? I think it's easiest just to like try and collect all the like terms. So yeah, what you can do is, yeah, okay, a couple of ways of doing this. I think what's easier, let's just multiply everything by 2. Okay, so we'll just get something like negative 7n squared plus 77n equals 6n squared minus 16n plus 14. And then let's just group like terms, yeah. So let's bring 7 this side, so we'll get 13n squared. 77 this side, so we'll get negative 93n. And then 14 stays 14. And of course now this is just equal to 0. And okay, now this is tricky. This is tricky because to find factors now, yeah, so you need to, again, this is, you need to solve this quadratic equation. And what I can say is, like, if you're uncomfortable factorizing when you have big numbers like 93 and 14, what you'll see is that the factors are very simple. But if you're uncomfortable factorizing, then just use the quadratic formula, or you can actually just use the quadratic formula on your calculator. I'm not sure if you know how to do that, but you can, just to get to the answers quickly. Unfortunately, there is a mark allocated in this question for factorizing this quadratic function here. There is a mark. So if you can't factorize it, you're gonna lose that mark, but it's fine. Save yourself the stress and time. Get the answers. There's a mark for the answers. Yeah. But so, like in question 1, if you've seen that video, I said, yeah, it's best just to write down the numbers you're trying to factor. Don't forget about the 13n, by the way. And just come up with some factors of these numbers. I mean, honestly, at this point, the only factors I can think of, maybe 7 and 2 for 14, and 14 itself. And you can just try a combination of positive and negative factors. So there aren't that many to try, so just try. You can also try positive and negative 14 itself. Just try some of these factors, different combinations, write it down. So you can, for example, just choose something like 13n minus 2, 13n minus 7. Which, by the way, these are actually the factors. But you can just choose, and then not 13n. Only one of them is 13. And then multiply it out using the FOIL method. see if you can get back to this. Yeah, just a bit of trial and error. So this is actually wrong. I just realized it should be the other way around. And this should give us back, so yeah, so 13n times n will get us out 13n squared. 13n times -7 should give us 91. -2 times n gives us -2n. -2 times -7 gives us +14. And this gives us 13n squared minus 93n plus 14. Yeah, so we get back to this. So we know that the factors are -7 and -2. Now if you're uncomfortable factorizing and you can't see, like, just do trial and error or just skip it and sacrifice the mark, because you can waste a lot of time trying to figure out the factors. But anyways, we figured it out. So it's n minus 7, 13n minus 2 equals 0. So n equals 7 or n equals 2 over 13. Now we must remember we're trying to figure out a term in the series. Yeah, so you can't have a term that's a fraction. This is just wrong. So the answer is actually 7. Yeah, so your final answer is n equals 7. Yeah, tricky questions, but yeah, I hope this video helps.